So on our first day of lesson 10A of our first lesson for unit 10, we're going to talk about converting between fractions and decimals. Notice as we're doing this, I have long division here because when you are converting between fractions and decimals, at least for this lesson so far, we're going to make sure to not use our calculators. We're going to keep our calculators put away. Do not open your Desmos calculator. We're going to remind ourselves how we do some long division. So we're going to take a look at just different kinds of decimals. We will have some examples of terminating decimals. We'll have some examples of repeating decimals. So terminating decimals are just decimals that end or decimals that stop. So underneath the word terminating, let's write end / stop, because terminating decimals would be like 1.5. That's a terminating decimal because it stops after the 5. Or 2.25. That's a terminating decimal because it stops at the end. A repeating decimal would be like 1.333, and then we put like a ... at the end to say it keeps going on. Or it might be like negative 4.1515 ... So that repeats as well. Keep in mind, if you have a repeating decimal, you can write it like this negative 4.15. You can write it as negative 4.15 and then just put a bar over top of it. And this bar over the top reminds you or tells you that the 15 keeps repeating over and over and over again. But keep in mind, putting a bar over the 15 is very different than just putting a bar over the 5. So this would mean it's negative 4.15555 and just the 5 repeats. If I want the 1 and the 5 to repeat, I would have to put a bar over both of them. So just some notation as we talk about repeating decimals. We're going to talk about how to divide these fractions, and I'll just kind of give us a reminder. Anytime you are dividing fractions, this top number goes on the inside, bottom number goes on the outside. Okay, so next to all of these, I'm going to write in and out, in and out. This one goes in. This one goes out for all of these examples, all 5 examples that we're doing today. Top number goes in, bottom number goes out every single time. Okay, so let's try a couple of these together. And I know some of these you might just know off the top of your head what 1/2 is as a decimal. We'll show how we get our answer. So the 1 goes inside, 2 goes on the outside. When you give me your long division, give me a nice big long division bar because you're going to have a lot of work over here. On the other side of it, it's going to be a nice big long division bar. And then here's how we think about this. So you are dividing by 2, which means you're telling me how many times does 2 fit inside of 1. Well, 2 is too big, so it fits inside of 1 0 times. And then we have to keep going. So you have to keep going until you get a 0 at the end. So when you want to keep going, you have to add a decimal. When I add a decimal here, I also add it here. That way I don't forget it. And then you can always add in extra zeros. Behind this 1 back here, you can add as many extra zeros as you need to. So I'm going to add in a 0, and then you're checking how many times does 2 fit into 10. 2 fits into 10 5 times. Okay, and then I just multiply 5 times 2 and subtract that away. When I take 5 times 2, I get 10. So I'm subtracting 10 and 10, which gives me 0. And then I always put a smiley face at the end of that because that makes me happy because it means I'm all done. So when I divide this, I get 0.5. And again, I know you probably knew what 1/2 was as a decimal, but there's just a little recap of your long division. Let's try another one. All right, so here we got 3 on the outside, 4 on the outside. Remember, top number goes in, bottom number goes out. Okay, so same thing. Check how many times does 4 fit inside 3. Well, it's too big, so it fits inside 0 times. Add a decimal in both places, and then you're going to keep adding zeros back here. Keep adding zeros until you're left over with a 0 or until some sort of pattern happens. So I know 4 goes into 37 times. So your 7 goes above the 0 in 30. 4 times 7 is 28, so take away 28. 30 minus 28 is 2, and again, you have to keep going until this is a 0, and it's not. So add a 0, and then drop it down. 4 goes into 20, 5 whole times. 4 times 5 is 20, so I'm left over with 0, which makes me happy. All right, so final answer here is 0.75. All right, and again, you may have known that one. Some of these common fractions, you might just know, like if I have 3/4, I have 75 cents, so that might help you with that one. All right, let's try number 3, this third one. So you want to keep doing your long division until you see a pattern. So let's set it up. 1 goes in, the 3 goes out. Go ahead and do your long division for this one. What do you get? All right, so we do our long division here. How many times does 3 go inside of 0? Well, 3 fits into 1 0 times, so put a 0 in a decimal. Add a 0 behind the 1 right here. And now you're checking how many times does 3 go into 10. Well, 3 goes into 10 3 times. 3 times 3 is 9, so take away 9. You're left over with 1. Keep adding zeros and dropping them down. 3 goes into 10 3 times. Take away 9. That's a 1. Bring down a 0. 3 goes into 10 3 times. That's 9. Take it away. You're left over with 1. So notice what keeps happening is you keep doing 10 minus 9 is 1, bring down a 0. 10 minus 9 is 1, bring down a 0. 10 minus 9 is 1, we'd have to bring down another 0. So what's happening is you find a pattern. So for this one, I'll put pattern down here just so I know. Okay, and I feel a little iffy about patterns. I like when it's a terminating decimal because I'm all done. These repeating decimals are fine, but you just have to make sure you write them correctly. So you can write 0.3, and then let's put a repeating bar above the top, just so to say that the 3 is repeating. And keep in mind, if it's a repeating decimal, you don't have to put 2 3s. If it's just a 3 that repeats, just put one of them, and then you're all done. All right, now let's try some of these other ones. So you have mixed numbers and you have improper fractions, but we're going to do the same thing that we did before. So this one is already written as an improper fraction, so I'm going to put this number on the inside, this number on the outside. I'm going to get the dividing started, and we'll see if you can finish it up. So this negative thing, I'm just going to bring it right over to my answer. So I know my answer is going to be a negative something. I just got to figure out what it is. So I'm going to do 11 divided by 6. Okay, I need to check 6 goes into 11 one whole time. Please put the 1 above that 1 of the 11. Make sure you're lining them up because I don't want us to be off at all. Sometimes if you put this 1 above the other one right here, our decimals are in the wrong spot. So that's a 1. Subtract away 6 because 1 times 6 is 6. 11 minus 6 is 5. Okay, now anytime there's nothing left to bring down, I can always bring down a 0, but here I have to put a decimal first and then bring down a 0. All right, so let's see. So I need to check 6 into 50. I know 6 times 7 is 42. 6 times 8. 6 times 8 is 48. So I'll do 8. 6 times 8 is 48. Take it away. You're left over with a 2. Here's a 0. Drop it down. We got to keep going until we find a pattern or until we notice something's happening. So again, I know 6 goes into 50 8 whole times. 6 times 8 is 48. So take that away. You're left over with 2. Drop down a 0. I know 6 goes into 23 times, so make sure that 3 goes above that 0. So 6 goes into 23 times, so there's my 3. 6 times 3 is 18. Take it away, you're left with 2. And then notice here what's happening is I keep getting 20 minus 18 is 2. I'd get another 3. And then I have to take away 18, and I would get 2 again. I'd get another 20. So my pattern is happening here, and what's happening with my pattern is that this 3 keeps repeating. Okay, so negative 1.833. All right. Okay, and then if it's a repeating decimal, you can just put a bar over the 3 and get rid of that other 3. That way you have less numbers in your answer. So negative 1.83 repeating. All right, last one. So if it's already written as a mixed number, this is kind of great because then you can just take this negative 6 and bring it right on over to your answer. And then all you have to do is 3 divided by 7. Okay, so let's do 3. Give me a big, long division bar for this one. 3 divided by 7. Remember, this number goes in. This number goes out. All right, go ahead and show your long division for this one. What do we get? All right, so I know that 7 goes into 3 0 times, but my whole number is not really a 0 because I already know it's a negative 6, but that's 0 times, and then I'm going to add a 0. Let's see. 7 times 4 is 28. Okay, you're left over with a 2. Bring that down. 7 times 2 is 14. And I know 7 times 3 is 21, and that's too big, so I got 6. 0. 5. Let's see. 6. 8. 7 times 8 will give me 56. We've got to know our math facts here. So 7 times 8 will give me 56. I'm left over with a 4. And I'll check to see what patterns are happening, but this one I'm left over with a 2, then I'm left over with a 6, then I'm left over with a 4. So nothing yet. 7 times 5 is 35. So I'm left over with a 5. Yikes. Okay. 7 times 7. Let's check see if you can see a pattern up here. I got 4, 2, 8, 5, 7. I'm not really noticing anything here. So I'm going to I'm not really noticing a pattern here, which I don't love. So I'm just going to put the first few numbers of my decimal. So just 4, 2, 8, and then I'll put I'll put the 5, and then I'll put a ... just to show that it keeps on going on. Okay, so what you'll notice is if your denominator is a 7, and that's just a quick recap, if your top number is your numerator and your bottom number is your denominator. If your denominator is a 7, you're going to get some crazy long decimals, like this 7 right here. If your denominator is a 7, you're going to get some kind of weird decimals. So just stop after 2 or 3. And then just make sure you put a ... at the end of it just to show me that it did not terminate. It did not stop. It kept going. It didn't have a pattern, but it did keep going. So make sure you put your ... right there. Another thing to notice is when you have a 6 in your denominator, you'll have some kind of a repeating decimal. And then also when you have a 3 in your denominator, you're also going to have some sort of repeating decimal. Those are your most, so 3 and 6 and 9 also is going to be repeating decimals. Alrighty, so please feel free to rewatch this just to kind of recap how to do your long division. Make sure we know how to do long division. Show me your long division. I cannot stress enough, the more organized you are in your long division, the easier this is going to be and the less mistakes we're going to make. So please keep everything nice and lined up. Notice how I did, or how I drew these arrows going down so I knew where these zeros were coming from. That just helps me keep my work nice and organized. So please keep your work organized as well, just so we can avoid making any careless mistakes. So feel free to rewatch any of these if you need a refresher on how to do long division, which turns fractions into decimals.